We're going to look through Unit 5 Progress Check Part C. I put number 1 on the same page with its choices. So here we go. On the right, it says the graph of y equals f of x is shown above. Which of the following could be the graph of y equals the second derivative of f at x? Well, what I'm noticing here is our graph. So maybe I should back up. When we have a graph of f, the relationship to the second derivative has to do with concave. So concavity, concave up and concave down. So I'm noticing that this graph looks like it's concave down till about 1.2 or 1.3, somewhere around in here. And then it switches to concave up for the rest. And so from what we've learned in the past, we know that if a graph is concave down until about 1.3 there, therefore the second derivative needs to be negative. So we want a graph that's below the x-axis from 0 to 1.3. And then after 1.3, it looks like it's concave up. So we want our graph to be positive after 1.3. Which means it's above the x-axis. So we want to be negative until about 1.3 and then become positive. So A is negative before 1.3, but still stays negative and barely hits the axis there. So it's not A. This is not negative, so that's not it. Looks like C could be our option here. It's negative till about 1.3, and then it's positive after that. And just to verify, it can't be D because D is positive to start with. So the answer is C. Number 2, I did write some things in here ahead of time, but it says 3 graphs labeled 1, 2, and 3 are shown above. One is the graph of f, one is the graph of f prime, or the derivative, and one is the graph of the second derivative. Which of the following correctly identifies each of the 3 graphs? So what I did here is I wrote out some things just for us to remember that we know. So if f is increasing, the first derivative is positive. So I'm just reading through these. If f is decreasing, the first derivative is negative or below the x-axis. If f is constant, which means horizontal or flattens out, and it can just be for an instant, then the first derivative is 0. Under that, it says f is concave up, so this has to do with the second derivative. Then the second derivative is positive or above the x-axis, and if f is concave down, the second derivative is below the x-axis. And then another thing to remember, if f has a maximum at c, the derivative will be 0 at c, it will be positive to the left of c and negative to the right of c. So it would look something like that. So there's horizontal, positive slope, and then negative slope. So above the x-axis, on the x-axis, below the x-axis. And if it's a minimum, it's kind of the other order. So let's take a look here. So what I did here is I wrote f, f prime, and f double prime under each graph, and I'm kind of going to think through the process of elimination here. So as we look at this first one, we have a positive, this is increasing, which means if this were my first derivative, if this were my original function, the first derivative would have to be positive up until about 1.5. Well, this one is not positive up until 1.5, and option 3 is positive for a tiny bit, but not up to 1.5, which means this one can't be my first derivative. It actually can't even be my second derivative. Sorry, it can't be the original function. It also can't be the first derivative because the second derivative is the derivative of the first. And if this were a function, neither option 2 or 3 is the derivative of it. So it can't be either of those, which actually forces it to be the second derivative. Now I'm checking down here in my options real quick. One being the second derivative is in these two, so it's one of those options. All right, let's move to this next one. This one is increasing. From 0 to about 1.5. And so that would mean my first derivative would have to be increasing from about 0 to 1. Or would have to be positive from 0 to 1.5. Well, that is not. So it can't be that one. Over here, though, this one is increasing. So in 1, it is increasing. So 1 is the derivative of 2. So 1 is the derivative of 2. Now let's check. So obviously it can't be these two. So actually, if 1 is the derivative of 2, this one has to be the second one, because the derivative of f gives me f prime. And then, so that means this one has to be the first derivative. There are other different ways to look at that, and that's fine, but we see that this has to be D. All right, number 3, I moved to one page as well, puts those same things down there. So this question says, the figure above shows the graph of f on the interval a to b, which the following could be the graph of f prime, the derivative of f on that interval a, b. Okay, so let's take a look here. We have it's increasing up to a little bit after 0, and then it's a maximum, and then it's decreasing. Maybe I should do all these in the same color. So this is decreasing, a minimum, blue is increasing, a maximum, orange is decreasing. Well, we can remember that if f is increasing, this first derivative should be positive or above the x-axis. If it's decreasing, it should be below. So our function should be above the x-axis, below, above, below. So above, below, above, below. So this is one way to think about it. So above, so B, well, let's start A. It can't be A. A does not start above the x-axis. B, it could be B. It goes above, below. So it could be that. C, above, below. It could be C. It can't be D because it's above and then it stays below for a while and then goes back above. So it can't be D. So it's either B or C. Another thing we can notice is it kind of would get us to the same point, but we know that maximums and minimums give us 0 derivatives, and maybe this would have been an easier way to look at it, but the derivative would be 0, so 0, 0, 0. Same thing here. So again, still have B and C, but we have to figure out if it's B or C. So let's look at concave up and concave down. So the graph changes from concave up to concave down. So concave up, so let's do different colors. Here's green. This is concave up till about right here. And then it switches to concave down to here. And then concave up again for a bit. And then concave down. And actually, it looks like it might switch one more time in there to concave up, except I colored over it so I can't see it very well. So one thing that we learned, which I did not write here, which I should have, is that if the derivative is increasing, that means my original function is concave up. And if my if my derivative is decreasing, f is concave down. And these can go both ways. So this should be, so at the beginning we're concave up. We should circle that in green. So this is concave up, which means the first derivative should be increasing. Well, the first derivative is increasing here, so B works. On C, the first derivative is not increasing, it's decreasing. So our answer has to be B. And you could kind of work through that even further just to make sure. This, I'm coming back up to my top graph. It's concave down from a little bit before the y-axis to a little bit after the y-axis. So concave down means the derivative should be decreasing, and so it's decreasing from a little bit before the y-axis to a little bit after the y-axis, and then it's increasing again. So it looks like B's still working, increasing, which means it should be concave up again, and it is. So the answer is B.